All right, we are live. So, I'm going to give it a couple minutes to let some people log in. I don't know that I've shared the live chat in Discord. So, there that is. There is that. Uh, those of you that aren't joined to the Discord, again, check your email or the email that I sent out, and there's a link to the Discord server. Here is what that looks like. There's a voice channel. I haven't been in it because most people aren't getting in it, so I haven't been sitting in the voice. But some people have been asking questions in that chat. And you can just take the link to the Discord. I think before next class I will make a video. Maybe this weekend I'll make a video and put it on my YouTube channel to kind of explain how everything works, or like do a walkthrough. Because the first years probably are gonna need it. All right, we got a handful of people watching, so let's get into this. What is the ampacity of a 1-gauge THW copper conductor installed on a raceway located at an ambient temperature of 55 degrees Celsius? So, there's a few things to break down. First, you're going to go to table 315 B16. That's actually a pretty good open image in new tab. This is probably the best version of this that I've found. So here is that table. Let me see if that website actually has oh, they do? Do they? No, that is not the same table. Okay. Then table it's not B2A. B2B? Yep, there it is. Oh, I do not want a YouTube video. I'm already doing that. Open image in new tab. Alright. And I should just bookmark these because I've had to go over them all week. Alright. So we got a couple more people watching now. What is the ampacity? My phone's going off in the other room. What is the ampacity of a 1-gauge THW copper conductor installed on a raceway located in an ambient temperature of 55 degrees Celsius? So let's clear this. Okay, we have, let me use a little bit thicker brush. There we go. So the important information from that question is 1 gauge and 55 degrees C. So 1 gauge. Whenever we look at this, you see that we have this chart, 315B16 Okay, my alarm is just going to keep going off. I will be right back. Sorry, that was my hey, if you aren't live streaming, you should be alarm. All right. So, we are on table 31015B16 looking for 1 gauge THW. So, if you see, the different columns have different types of insulation listed, and you will look for the insulation type you're using, which is THW in this question. Number 1 is on this column. You come down to number 1, and then in the 75 degrees Celsius column, you have 130 amps. So we'll come over here and write down starts out at 130 amps. Now, of note, we need to read the title of this. You don't have to read it every single time, but there's some important things in the title of this table. Not more than 3 current carrying conductors in a raceway, cable, or earth. So if you have more than 3 conductors in the conduit, you cannot use just this table. Based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If you are using the wire somewhere that has a different ambient temperature, you need to adjust this ampacity also. So, those 2 things, so not more than 3 current carrying conductors in the raceway, and not different than 30 degrees Celsius. We are just talking about a single conductor, so we don't have to worry about more than 3. But we do need to worry about for ambient temperatures other than 30 degrees Celsius. We are using a 75 degree Celsius wire, so we will be in this middle column, and the ambient temperature is 55 degrees Celsius, which is like 131 degrees. This must be like a rooftop in Arizona or something. Anyways, so if you come down, you have 51 to 55 degrees, and your multiplier is 0.67. So you'll come to your paper, 130 amps times 0.67. I would show you me doing the math on the calculator, but this is fine. 130 times 0.67 is going to be 80. I want to say 84. It's 80 something. It's 84 or 87. It's 87. Alright, so that is 87 amps, is the actual ampacity of that conductor. You can see as temperature goes up, see, because we are at 55 Celsius instead of 30, as temperature goes up, your ampacity is going to go down. Because the wire won't be able to dissipate as much heat, which will burn up the insulation faster. I'll come back to that question later. A conductor's allowable ampacity is directly related to the type of insulation used in the conductor. Yes. Just looking at this, different ampacities, different insulation listings. Table 31015B16 can be used when there are not more than 3. Covered that already in that first question. And I covered this in that first question also. Table 31015B17 applies to the single insulated conductor installed in free air where the heat generated within the conductor can be more easily dissipated than where the same insulated conductor is enclosed in a raceway or cable jacket. So, 31015B17, if you open up your code book, has a title about its free air. You just have to look that up, and you're right there. A single insulated 2-gauge THW copper conductor installed in a raceway in an ambient temperature of 30 degrees Celsius will have less ampacity than when installed as open conductors in free air at the same ambient temperature. So what this is saying is, if you enclose a set of conductors, it will have less ampacity than if it's just in free air. All right. 3, number 10, FEP copper conductors. Now this question directs you to a new table and a new temperature correction chart. So you will use table 31015B18 to get your original ampacity, just like we did for question number 1. And then you will go to, let me flip my page. I should just move my code book over here. That way my tablet can rest on that page. Alright, 31015. B18. We are looking at 10 gauge FEP. Number 10 FEP is 60 amps. So let's clear. I can do it down here. So 10 at 60 degrees Celsius. Now we have 60 amps, and we have to get our multiplier. You won't go back to that same table that you use, the B2A table. You won't go back there. You'll go to table 31015 B2B. Because this, if you look in the title of 31015 B18, the one we were just directed to, you will see that it is based on an ambient temperature of 40 degrees Celsius. So you need a temperature correction factor that is based on 40 degrees Celsius. So whenever we come here, FEP insulation is a 200 degrees Celsius insulation. So you will use the column for 200 degrees Celsius. 60 at 200 degrees is 0.94. There's so much noise in the background of my live stream right now, and that's a little bit annoying. Okay, 60 amps times 0.94. So 60 times 0.94 equals 56.4. So that'd be 56 amps. I have a robot vacuum, and it decides at 11 o'clock every day to vacuum. Which would be a simple enough thing to just change it to like 11:15 when I'd be done. But that's not for me. I'm not about that life. Size 12 gauge aluminum conductors within a UF cable are generally considered to have the same allowable ampacity as 12 gauge aluminum single conductors when marked. So, UF cable, again, looking back at this. Nope, that's the wrong. 31015B16, UF and TW share a column. You could write in your code book Romex also on here because Romex is this column as well. But UF and TW. Temperature rating of THWN, again, we're going to look over here, find THWN. It is 75 degrees Celsius. THWN-2. -2 means it's a 90 degrees Celsius wire. That's what the -2 means. Branch circuit is defined as in the NEC as the circuit conductor between final overcurrent device protecting the circuit and the outlets. Yes, that is the definition of branch circuit. That will be in Article 100. We are getting into Lesson 3 stuff now. Also, definitions. This applies for, again, definitions. You'll look up all 4 of these and see which one applies. Number 14, because of a long circuit length, a branch circuit supplying parking lot lighting. So, this one is, you'll actually look in Article 210, which is branch circuits, and you'll be looking at ampacity ratings. 210.18 is going to be your goal. Branch circuit ratings is the keyword that you're looking for. Branch circuits, then branch circuit ratings. And basically it's saying that the rating of the branch circuit is basically the weakest link. You will put the breaker is the what sets the rating of the branch circuit. This doesn't have to do with the 80% factor. The rating, the 80% is based off of the rating. It's a chicken and egg situation. Each multi-wire branch circuit shall be provided as a means which will simultaneously disconnect all. Okay, so multi-wire branch circuits. So you'll look up branch circuits, then multi-wire. It's very early in the section, so 210.4b. It's like the one of the first couple paragraphs. Y'all got it. Good job. Branch circuit voltage for luminaires in a dwelling unit is limited to 120 volts. Voltage limitations is the key word here. Branch circuits, then voltage limitations underneath branch circuits. And once you've got there, it will take you basically right to this. Which of the following commercial locations generally do not require GFCI protection? So branch circuits, then ground fault circuit protection. Is finished portions or areas of the basement. There is a list there in other than dwelling units. There is a list that will have everything but finished portions or areas of basement. And in dwelling units, basically the same question, but about dwelling units, and it's finished basements. Uh, the grounded conductor of a branch circuit is mostly identified as by the color white or gray. Didn't put a code reference in the explanations, but you look up grounded conductor identification. Receptacles rated 15 amps are permitted to be installed on both 15 and 20 amp branch circuits. This one is branch circuits and what was that one? Devices. Branch circuits. Something about devices. I can't remember. It should be, oh, here it is. Table 210.21B3, receptacle ratings for various size circuits. So, circuit rating 15, not over 15 amp receptacle. A 20 amp circuit can have a 15 or 20 amp receptacle. And part of the reason for that is that the facing on a receptacle, like a 15 amp receptacle has that. A 20 amp receptacle has that. And a 20 amp plug, the prongs look like that. So that you can't plug a 20 amp plug into a 15 amp receptacle. So you couldn't pull 20 amps out of a 15 amp receptacle even if you wanted to, because they have blockages. Alright. Was the maximum load in amps per node to be cord and plug connected to a 20 amp multi-outlet branch circuit? So that is directly above the last question, table 210.21B2. And it's 80%. You can't put 80%. So cord and plug connected is 16 amps to a 20 amp circuit, multi-outlet circuit. Maximum rate. True. A multi-wire branch circuit for an individual piece of utilization equipment supplies a line to neutral load. That is actually the only acceptable. You cannot go line to line with a multi-wire branch circuit. Basically, you can't have 240 volts on a multi-wire branch circuit. A multi-wire branch circuit is basically a circuit that shares a neutral. You have multiple different loads or multiple phases that share a neutral, and then you can't also connect a 240 volt load to it, because that throws everything off. Yeah. In dwelling units, the voltage between conductors that supply luminaires shall not exceed. Already answered this one. Should just be a recap of a previous question. A 125 volt single phase 15 or 20 amp rated receptacle installed for servicing AC equipment for a commercial building. Oh, so this is branch circuits, and and then it should be required outlets, and then heating, air conditioning, and refrigeration equipment, which is air conditioning equipment. And that's 25 feet. You have to have a courtesy receptacle within 25 feet of your AC equipment. Also, service equipment. It's a whole different section. So this last one was 210.63, and then if you look in 210.64, it's basically the same requirement, but it's specific to electrical equipment, electrical service areas. You can kill two birds with one stone by putting a plug that's within 25 feet of your service and your AC unit. Also in required outlets, hallways, required outlets, then hallways. Same page. I'm going to cheat, and 210.52H is the length of a hallway that requires a outlet. If you have a floor outlet that's within 18 inches of a wall, it counts as a required outlet. This is the electrical service equipment question. Electrical service equipment would be the keyword there. That again, that is 210.64 is where you're going to find that. All right. Well, that finishes this quiz. I'm going to start the new quiz now. So that's quiz 4, or lesson 4. I'm giving y'all. Let me know if y'all prefer, like, one attempt lets you leave and come back and finish the same quiz that you were, like, not have to re-answer the questions. But not one attempt, you can do it multiple times. I think I prefer the not, like, being able to do it multiple times for you guys. But let me know what y'all think, which one you would prefer. And then I'm going to code review. Again, that's code review room. I bumped my vacuum button. And I'm going to start the lesson 2-3 quiz in that room. All right. That's all I've got for you guys right now. Have a good lunch. Yeah, I figured multiple attempts is what y'all would rather. Okay. Y'all have a good lunch. I will see you guys again in, I believe, 2:45. Is that right? That seems late. But I will see you guys again at the next scheduled. It's 1:45, just to correct myself. 1:45 is the next live stream. See you guys then.